exercise 10.5. And 10.5 is talking about conditional probability. So this is another question where we're trying to draw a more complicated two-way table. Okay, so let's discern the information. We know the disease and only 2.5% of the population is infected. So in the population, they can have either have disease or not have disease. We know the total that do have disease are 2.5%, so it's 0.025 as a decimal. I know that the rest of the population don't have disease, so that's 0.975, because the total has to add up to 1. Now, it also says there's a test available to test whether someone has disease or not, but the test isn't completely accurate. So the test can either test positive or negative. Okay, and we know that 95% of the time, the test correctly identifies the disease in infected patients. So what this means is, for this column, for this box, we know 95% of this, 95% of the people that do have disease are tested correctly. So it means that 95% of 0.025 are tested correctly. So it means that when I want to calculate the actual value, I go 0.95 times 0.025, because that's 95% of 0.025. And I should get a value of you enter this on your calculator, decimal mode, 0.02375. 0.02375. Now, it also gives me another piece of information, because I can't fill in the rest of the table without another piece of information. It says that the test incorrectly identifies the disease in 7% of the uninfected population. Okay, so if you're uninfected, this test is somewhat inaccurate, so it still gives you, say you are infected, 7% of the time. So what that means is 7% of the uninfected population, the test will say they're infected. Okay, so there's a degree of error here. 7% of 90.975, so 0.07 times 0.975, are testing positive even though they don't have the disease. So when I work that out on my calculator, I get 0.66825, 0.6825, so 0.066825. I'll draw that better. 0.06825. 0.06825. Now, I've got enough information to fill in the rest of my table, because this box is simply 0.025 minus 0.02375. So I get 0.00125 on my calculator. This box is 0.975 minus 0.06825. I get 0.90675 on my calculator. I add the columns together. I get a total of 0.092. And I add the total here. I get 0.908. And they should all add up to 1. Okay, so that's the hard work done. We just need to find out the conditional probabilities for part B and C. So the probability that they have the disease, so disease I just use shorthand as D, given that they test positive. So in other words, what is the probability that they have the disease and the test says they have the disease? So given that it's positive, so we always look at the given, what's given. So given that they're positive, we're actually looking at this column, because this is where it's positive. Given that they're positive, what is the probability of getting them having disease? So we can see that from the table, they have the disease here. Okay, and this is our total, and this is our total. So our total's 0.092. So our new total is 0.092, and we want to find out, given that I have the disease, 0.02375. You enter that on a calculator. Again, it says 2 decimal places, so you make sure in decimal mode. You should get 0.026 when you enter in your calculator. For part C, probability that they don't have the disease, so I'll put D dash, given that the test comes out negative, okay? So, given that they don't have the test is negative, given that the test is negative, so I'm going to put a highlighter, I'm looking at, possibly do it in a different color. I'm looking at the blue region, okay? Because this is where the test is negative. Given that the test is negative, what's the probability they don't have disease? Don't have disease is this part, okay? So I'm interested in this. So the total is 0.908, because that's my new total, or the new sample space. And out of that sample space, the one we want is that don't have the disease, which is 0.90675. When I calculate the probability, I get points around 0.999. Now it says to do to 3 decimal places, so what it's saying is that if you don't have the disease, 0.999% of the time, you're not going to get tested positive. Or another way of saying it is that if you don't have the disease, it will say you don't have the disease 99.9% of the time. And that is how you do this.